My name is Bruce Johnson. I'm engineering manager and creator of GWT. Today I'm going to be talking about a topic that we don't get a chance to go into depth on very often because it's pretty technical. And let me tell you, you're in for a treat. But it's not because of the content of my talk. It's actually because I have chosen to violate every best practice of public speaking today. They say show up on time, and I'm like, no. I am wearing pants. That's true. So I'm maybe I'm at 0. But let me tell you some other things they say that it's good to do that I don't plan to do today. They say rehearse, and I'm like, no. They also say a well-structured presentation has different sections, and you tell people what you're going to tell them, and then you tell them, and then you tell them what you told them. Again, not this presentation. Instead, we've been working on GWT 1.5, and what I've done is produce this nice walk through deferred binding in a set of slides that I've never even rehearsed. So, if I say something that doesn't make sense, don't hesitate to call me out or ask questions. I hope that the actual point of all this will become clear as we go on. Okay. Well, actually, faster than possible. Okay, come on. I had to entice you with something that sounds unbelievable. It's only faster than possible if you aren't using an approach like deferred binding, which is why we are using an approach like deferred binding, because we want things to be as fast as they can possibly be when you use GWT. It starts from our mission statement, which, if you haven't read it, is this. GWT's mission, I call it GWT, I'm sorry, sue me. GWT's mission is to radically improve the web experience for users by enabling developers to use existing Java tools to build no-compromise Ajax for any modern browser. So the web experience for users as in end users is what is important. We want it to be easy to develop too, but what we really care about is that when a user uses an application built with GWT, they feel like it is a good experience, and speed is critical to that. Also, we call it no-compromise Ajax. We don't want people to view using GWT as some sort of, well, it's easy to use, and the results don't totally suck. Nothing like that. We have this opportunity to cross-compile from Java into JavaScript. Why not optimize the hell out of it in the process? That's our attitude. A couple more baseline kind of philosophy setting quotes here. We definitely do not view development in GWT as a form of compromise, as I said. We believe that GWT should generate better JavaScript code than you would write by hand, and we will generally choose to avoid making any sort of concession to convenience for developers if it hurts the performance of the resulting Ajax code. In other words, we're really serious. Let me belabor the point that much more. We want great results where great is defined by the end-user experience. So we look at GWT as a solid platform upon which you can build very ambitious applications. It has a library, a really comprehensive set of libraries, in fact. But that's not fundamentally what GWT is. You can take those libraries or leave them. You can build your own libraries, as many people in the open source community have done. The underpinnings, including deferred binding, that is what GWT is really all about at the lowest levels. Hopefully, as we go through this, you will see how you can use it yourself. The basic premise of deferred binding. Fairly modest goal. The best possible performance from a web browser. As determined by the end user, we want very fast startup, and we want the execution of the application to be extremely fast while it runs. So the ideal concept would be send exactly the right code for the user in their circumstance. No code that they don't need, and exactly the code that they do. What kinds of things determine a user circumstance that might affect what code you send them? Things like the user agent that they're running. I don't want to send Firefox code to an Internet Explorer user. That's a waste of bandwidth and a waste of time. Things like Locale. I don't want to send French messages to a German speaker, for example. Whether the application is a debug build or a production build. Perhaps there's a mode where a customer's having a problem in the field. I can send them a different URL, and they get a different version of the app that has extra logging and things like that. That's cool that you can have that, but you don't want to pay for that capability in your normal production application. So ideally, you'd only send the debugging code in the version where the user is actually having a problem. Other things like network characteristics factor into this a lot. Maybe the user has a particularly slow network connection, and you can either have low bandwidth, low latency, or some combination of the above. You want to make sure you're not wasting any time at all sending things that are irrelevant. But no single script, no one JavaScript file could possibly satisfy all these different criteria. So you modularize. This is what developers do. It's what we spend a lot of our time thinking about when we architect ambitious applications. You want user 1 to have the application code and maybe just the Firefox code and the US English locale, but another user is in the UK and they're running IE6, so you want them to only have those chunks of code. This is the visualization of what I was just describing. So the obvious way to approach this that sucks is to use something like the service provider interface. If you've seen that technique in Java, you create a nice common interface, and then you load exactly the right implementation dynamically. So, for example, if you want to have a cross-browser abstraction layer, I create an abstract browser interface, and then I write my code against that. Then, when the application starts to run, it looks around and says, oh, okay, to provide this service implementation for this abstract browser class, I need to go fetch the IE version or the Firefox version or the WebKit version. But as a matter of fact, and you do that dynamically using HTTP. But the problem with this, the first rule of Git Club is make fewer HTTP requests. HTTP requests kills you, and if you've read Steve Soder's book, High Performance Website, it is the #1 rule. Don't make HTTP requests where fewer would suffice. If you look at the Git mail sample, you can actually count the requests, and it's 3 or 4 when it's uncached. And that includes all the images and everything else. That is the kind of small number of HTTP requests that produces great user experiences. If I didn't make it clear already, actually attempting this is the total suck. And because what happens is the app starts, and then maybe a little something happens, and then you have to wait to go fetch this 20K script, and then that comes, and then it can continue running. It's a terrible way to use the network. And there's an outgoing connection limit in modern browsers of 2 HTTP requests simultaneously. So if you go queue up requests for 30 different little JavaScript modules, guess what? You're only going to get a maximum of 2 being fetched simultaneously. So you create this huge backlog. Meanwhile, the user's twiddling their thumbs and thinking about going over to Twitter, and you lose them. And this is particularly painful if you're developing for mobile devices where you have problems with bandwidth, with latency, and even ones like the iPhone has good throughput. Once you make a connection, it's slow to make the connection in the first place. So it's actually the number of connections that dominates performance, not exactly the number of bytes. And then even if you get the code down there, it's slow. It's slower than it should be because you have had to construct your JavaScript code to use polymorphic dispatch. Again, you've coded against this abstract interface, and you provide a concrete implementation that requires an indirect call, a dynamic dispatch, every time you interact with that API. And something even near and dearer to our heart is you can't eliminate dead code under those circumstances because you don't know which implementation is going to be called. So let's say you have an API that has 150 different methods, okay? The abstract browser class has 150 methods. The Firefox implementation class has 150 methods. Only 3 of those get used at all in this application. Guess what? I still have to send down the code for all 150 because I don't know which ones might or might not be used due to the indirect dispatching required through polymorphism. And if that's not all bad enough, it's hard to maintain these kinds of systems. What if you have a network hiccup during the 24th of 42 requests? I mean, what kind of state is my application in at that point? This is a nightmare. And even if you kind of succeed getting all those things down, actually rationalizing the whole system in your head is very confusing. I call it the web equivalent of DLL hell. So, okay, we can all agree that that's not a good way to approach this. Another idea that you might have to deal with cross-browser issues would be capability detection. And this is the conventional wisdom of how you ought to do cross-browser code. Let's not test for specific user agents at all. This is very elegant. We'll just see, does it have inner text? If it does, we'll use it. If not, we'll do something else. So you end up with code that looks like this scattered throughout. And here I'm talking, I'm kind of comparing against how you would write things by hand in JavaScript. That's because I'm going to set up a contrast to the way that we do it with Quit. Okay, so set inner text is not a feature that is implemented the same way on all browsers today. Okay, so if I'm going to try to create a cross-browser API around it, I have to create a function. Then that function does something like this, capability detection. It does some sort of sniffing to see if it has inner text available. If it does, I use it. If it doesn't, I do something really horrible and slow, like remove all the child nodes and create a text node and append it. Okay. This is based on real JavaScript code in a respected library that I've seen. So this brings us to the second rule of Quit Club, which is make fewer HTTP. Wait a second. Sorry, I digress. But still, it's very important to make fewer HTTP requests. Let's go to the I just reflexively say make fewer HTTP requests because that seems to dominate the startup time. Pardon me. Okay, the capability detection path does not lead you down the right road ultimately. Not that it's not a good concept, it's just that as a practical matter, it doesn't work as well in practice. Because when you do it naively, as in the code example that I showed you, you're having to do a repeated if-then check every time I call this method. And this is a leaf method. If I've got a 40-column table by 1,000 rows or something, and you want to set the text in every single cell, that is some heavy usage, right? So this needs to be fast, and you don't need to be testing for things like, which browser is this? And then each time you forget, not which browser, but what is this capability available? You don't want to do that in a critical loop. Again, this is, and this generalizes to any way that you try to do cross-browser abstraction. Does it have the capability? If so, use the good way. Otherwise, do the max power way. Have you guys heard of max power? It's from The Simpsons. No? Anybody? No. All right. It's one person. Well, it was a hilarious joke if you actually got it. Homer dons this persona of max power, this crazy guy who has kind of superpowers, like domestic superpowers almost. And he says there's 3 ways to do things: the right way, the wrong way, and the max power way. And Lisa said, but isn't the max power way the wrong way? And he says, yes, but it's so much faster. So max power means bad for the rest of the references to it. But you're smarter than this. You realize you don't have to do this test every time, right? So you're going to improve your JavaScript abstraction. You're going to call a one-time setup function that at the beginning of the app checks to see whether or not this capability is available. And if so, it sets up indirect calls on essentially like a vtable in C++. So that from then on I can say browser.cross-browser method, and it is automatically bound to the right implementation. But the third rule of Quit Club is, as Joel Weber, the co-creator of Quit, said, he's a bit of a performance geek, the fastest code is that which does not run. He's also said the fastest HTTP requests are those which do not, in fact, occur. But I think I've harped on that point enough. So, back to inner text. What you really, really want in the application code is the following. You want a bunch of code to do your app stuff. You want a statement that says element.innerText equals string. You don't want to call a function per se. You had to call a function in order to make your code base maintainable. You had to introduce that level of indirection and abstraction to create the cross-browser portability that you want out of your library. But that's not what you want. What you want is this code. But obviously you can't write this code you can't write this code and then expect this same code to work on every browser because not every browser recognizes the inner text property. So sometimes that's not possible, in which case, if you're on a browser where you don't have inner text, but you do have text content, like Firefox, you want to write, I misspoke. This is the max power way, basically. Either you optimize for the particular browser if you know that it's there. Otherwise, maybe then you can kind of degrade to a little bit more heavyweight way or something like that. And if you look at the code that I showed you before, it's the set inner text where you remove all the child nodes in a loop and then you create a new text node and append it. clearly that's something you wouldn't inline here, so you would call a method, and that's what I'm showing. So again, you want inlining, and you don't want to pay for abstractions at runtime. So the question is, look, does this really matter? You guys are very preachy about this. I'm really getting tired of you bragging about compiler optimizations. That's fair. So the question is, does it matter? And remember, we're not trying to impress developers. We're trying to impress end users. So the only test of whether something matters to us, really, is whether or not it makes a difference for end users. So does it? I'll just measure these three things and see what happens. So how many times can I call set inner text in 1 second? Going back to the grid example, that's a very relevant thing, because the faster I can set inner text on each of those cells, the quicker the app can respond. So I set this up to do all three different scenarios. This is done on Safari. The capability detection, where you test it inline using an if-then statement. The polymorphic approach, where you set up the function pointer ahead of time at the application beginning. Or where you inline the inner text call directly. And as it turns out, the first two approaches, both of which took you more effort, had essentially no measurable difference. So even the if-then statement is not particularly slower than making that extra function call. But the inline code is 10% faster. On some browsers, it's even more dramatic. I saw as much as 20%, but I didn't want to oversell the point. In other words, I can do, in any 1 second, I can do 10% more code. The more glaring the differences are between the browsers and between the different use cases, the larger this percentage can become. We've done real measurements comparing JavaScript libraries written by JavaScript experts against GWT code that does the same thing. And our compiled code was, in some cases, 50% faster. The other point is that, so this is Safari, but different browsers have different, sort of quirks, and polymorphic dispatches are fast on some browsers, they're slow on another browser. One thing you can be sure of, though, is that inline code is going to be the fastest possible way to get it done. Okay. So actually, yeah, my little graphic here. Permutations. This is where we start to really dig into what deferred binding is all about. Okay, I've described like this ideal world where you've got some set of inline code in one browser and some other approach in another browser. You have to wrap all this up in a sane programming model, right? Because if you can't actually achieve these results in practice, then it's not really that valuable. I mean, I could write a version of my JavaScript specifically for IE. I could write a whole other version specifically for Firefox, and I could achieve those same results. But nobody's going to do that. You need a programming model that gives you these benefits without, having to go insane by having duplicated code. So what if we use polymorphism as an axis of permutation, at which point we can branch the different implementations? We've already sort of touched on this, but let's be a little more specific. So in GWT we have a DOM-impl class, which is an abstract class, and then we've got subclasses. Very much like the SPI pattern I mentioned before. But the gwt.create call is where the magic really happens. Whereas in the service provider, the SPI, the service provider dynamically loaded modules case, you had to load things sort of on demand as they're used. Gwt.create does something totally different. When I say gwt.create of type t.class, it gets special treatment from the compiler. It acts as a sort of pivot point for different permutations. And basically your code, single Java source code base, but it forks at that point. You don't have to actually see the forks per se, but the compiler does this for you automatically. And everywhere you had gwt.create t.class, it gets replaced with a more specific substitution class. And it gets rewritten as simply new t prime. In each different fork, it's as if you had explicitly instantiated the subclass. So you can write gwt.create t, but it is as if you had written it multiple different times redundantly for different specializations. This is the code example of what I just said. Does this Make sense? This is where it starts to get a little, metaphysical and kind of weird. Does this basically make sense, though? Okay. This is also why t.class, the argument to gwt.create, must be a class literal. The compiler is the thing that does all this branching. It's not a runtime thing. It's the compiler. So that means the compiler has to know which class you're trying to use as a permutation axis. And in general, compilers, there is no sort of general way to know if that had been a variable, what value the variable would have had at that moment that gwt.create was called. Consequently, it has to be a class literal. Now, I'll digress for just a second to talk about the goodness that is monolithic compilation. Okay, we've already said dynamic loading is bad because of HTTP requests, but let's look at Java. It's still a very dynamic environment. You've got the ability to do class.forename to load classes on demand, and then class.newInstance to instantiate new methods. You've got reflection at runtime that you can use. It turns out that if the compiler is able to eliminate those two things, and if you know all the source code up front, I mean every single class that could possibly be used when you compile, no dynamic loading, nothing like that, the compiler can do some crazy cool optimizations. This is really never done in practice because most big systems tend to have some kind of dynamic loading capability. So like in desktop applications for Windows, you've still got DLLs, and you can't compile in DLL code. It's got to be loaded separately at runtime. But in the case of GWT, we're going there. We're taking it all the way, and by eliminating reflection, eliminating dynamic class loading, we can optimize the heck out of your code. Let's look at an example of what we call type tightening and where that leads us, okay? Typical polymorphism example, I've got a variable of type shape, and I instantiate a square, okay? The square has, each side is of length 4. Then I make a polymorphic call to shape.getArea, right? This is like OOP 101. But the compiler knows that, and imagine now that instead of it being explicitly written as new shape, it was a method call. So that you can't really know at the call site that it's a square per se. It could be anything in theory. Well, the compiler can look into that function and see that, in fact, this always returns a square. So even the addition of extra levels of indirection doesn't always frustrate the compiler. The compiler can say, all right, well, I know that shape is actually going to be a square, so I'm going to tighten the type of that local variable to square. What that means is the getArea call doesn't have to be polymorphic. The compiler, because it knows the entire set of classes, it knows that nothing ever extends the square class. Consequently, every method on square is essentially final. Consequently, there's never a need to do a polymorphic dispatch at runtime. Consequently, we know that the method that we are calling is definitely the getArea method on the square class. Now, once you know that, you eliminate an extra hop at runtime, which is great, because as we saw before, that costs you 10% slower just to get this abstraction. That's no good. But even better, now that the compiler knows exactly which method we're going to call, you can imagine, what does getArea look like on square? L times L, right? Why not just inline it, right? And that's what our compiler does. So you've seen polymorphism go away, which gives rise to inlining, which makes your code faster. And in fact, if we're smart in the way that we use heuristics to decide when to inline and when we don't, it actually makes your code smaller too, which in the case of script means that it actually downloads faster. So you're sending down less code that runs faster because we've given up this idea of dynamic loading and reflection and all that. Now, we have some cool ideas. This is a bit of a teaser, and honestly, it's still vaporware, to be honest. But in GWT 2.0, we can envision a compiler optimization that would take this even further and give you this. Now, we've whiteboarded how this would work. In fact, if this was the only code, there really is no reason to even create the square object in the first place. This is how crazy we are about performance optimizations, and this is why with each new release of GWT, you see that your code really gets a lot faster. It's because we're doing crazy stuff like this. Okay, So that is the value of monolithic compilation. Let's take this back to the concept of permutations and forking. Okay, I showed you, I talked about DOM-impl, and we have two different implementations here. If you haven't seen it before, if you're new to GWT, oh, and by the way, if you're new to GWT, my apologies. This is all like super advanced type, low-level stuff. There are a lot of great resources on the web, and you can talk to there's several GWT team members here and other Googlers who would love to talk to you about it if you're like, this is nuts. Just what does it do? So anyway, I was going to show you here that you've got in the top of the bottom two code boxes, DOM-impl Mozilla implement set inner text using the text content property. And that is a native method, if you see there. That's the way that we interoperate with JavaScript. You can just write JavaScript as the implementation of a Java native method. It's called JSNI, the JavaScript native interface. And then in the Internet Explorer case, you implement it using the inner text property. In other words, you've got the ideal fast implementation in both cases. It's just that you can't put those in the same compiled script. So we branch reality. Now let's think back about the monolithic compiles, right? Each one is branched. It is compiled monolithically. So the version we're optimizing for IE doesn't give a crap about the way that it's implemented on Firefox. It can inline all the way back down. And so a call, as you see in the top example here, to impl.set inner text, where x is some element on the page and foo is the string that you want to assign to it, literally becomes, in your application code, x.textcontents equals foo, or x.innertext equals foo. You get two different JavaScript files. Each one is perfectly optimized for the environment in which it's intended to run. Does that make sense? Give me some love. All right, that's good. All right. Now, we really talked a lot about user agent, but I'm happy to say that deferred binding is really a general mechanism. After all, the things we talked about at the very beginning of the talk, it wasn't just user agent, right? It was locale. Things, even more advanced things like canvas, like vector graphics, I should say. I mean, vector graphics, like today's browsers can do vector graphics, but they all do it differently. On Firefox, you have SVG. On Internet Explorer, you've had something called VML that is a really nice 2D vector graphics library that has been around for years. Google Maps uses it for driving directions. And then on the WebKit family, you've got Canvas, which is a really nice, fast 2D vector or graphics library. You can see how you can use deferred binding to create a nice high-level vector graphics library that gets mapped extremely efficiently onto each of the different underlying libraries, which are themselves very different from each other. You still get to program to a consistent abstract interface with the full comfort of knowing that the most optimal results are going to happen in each case. Locale is another example I want to use here. Nothing special. Again, just like I talked about vector graphics or user agent, Locale is another way in which you might branch your application. We've got this well-known messages class. It's just part of the GWT libraries. It's a tag interface. I'll come back to why that interface is useful as a tag interface in a second. It has no methods. I extend it and create my messages as a class that contains a bunch of messages that can be localized for each locale. Then I do a gwt.create of my messages.class, which causes the deferred binding infrastructure to run some code that substitutes in some subclass in each different branch. We branch along the locale axis, and then in each branch we substitute in the localized implementation of those messages. So if in one permutation, the gwt.create of my messages becomes new my messages for US English. In another case, French is spoken in France, and then in another case, French is spoken in Canada. It is as if you had handwritten each one specially, but it just happens magically. Now, the way that you actually rig all this stuff, the way that you can leverage it yourself, because again, this is not special, it's a general purpose, open-ended set of technology that we've used to sort of dog food the first libraries, but you can use it yourself. It's all based on this idea of client properties. Client properties are what sort of dictate which permutation ought to get used within a particular setting. It also dictates the axes on which you basically just split, right, your different code bases. So you can define properties in your GWT.xml module files, like this in the Locale example. You can specify multiple values for a property. You can extend a property that someone else defined. So, for example, I have a few locales defined already, but I want to add a couple more. For each one of those, it potentially creates a new permutation. I can also do something, which is to fix the value of a property. And this, it basically overrides every potential value, and it says, no, for this compile, this property has exactly this value. Now, this is really useful, especially in development, because you can actually generate quite a lot of permutations. You can imagine the cross product of several different axes in terms of client properties. So the numbers of permutations gets big quickly. During development, that can lead to slower compiles, which is annoying. So what you tend to do is just set a property in your module XML, in a working version, the development time module XML. You set the property to a one fixed value, and so it does not create permutations along that axis. Here's a really concrete example. People want to compile really quickly, so they'll set property user agent equals Mozilla. And then instead of getting, the compiler taking the time to produce all the different permutations, it just produces exactly that one. And again, if you've got a really complex app, apps at Google often support 40 different locale and 7 or 8 different browsers. So that becomes a big number quickly. I can set those property values to a fixed value in all those cases and basically produce just one permutation. But I'm a simple XML element away from all the permutations or only just one. Properties actually get their values through something called the property provider, which is a bit of handwritten JavaScript that you write in your module XML file. Here's an example, a trimmed down example of the one that we use to decide locale. User agent has a similar one. It does things, and they're open-ended. You can decide. You write a snippet of JavaScript code that somehow provides a value for this particular client property. Okay, so you only have to think about that one properties provider. So Locale works by looking to see if there's a query parameter called locale, and if it says locale equals ENUS, then I know that that's probably the value that I should send back. If it doesn't find it there in the second if statement, it will go and look for a meta property in the host HTML page to which this module is attached to see if there is a property called locale. So it gives you a couple different ways to specify properties if you want to. If it still didn't find one in either of those two cases, it uses a default locale. And then suppose that it did find one, it does something where it tries to match the closest. If you've compiled, say, for just EN and not ENUS, it starts ripping off suffixes and finds the closest one that you actually did compile for. Anyway, the point is that you return the property value. Each of the property providers runs. You get a set of values, and that dictates which permutation you want. So how does the compiler actually resolve a gwt.create statement? How does it decide what permutations to do? We've talked about the client properties and their role. But it actually somebody has to say at compile time, not at runtime, at compile time, which are the different replacements for this particular t.class class. So your module XML has a bunch of rules. And you can inherit them and you can define them. They're consulted in reverse lexical order, and all I mean by that is that your module, which is the one that you're compiling, gets a veto. In other words, if you define a rule, yours will win over anything else that you inherit. You need to think about that if you're creating libraries that use deferred binding, because you want to have good defaults that makes sense. But you also want to know that other people, you should remember that other people might want to override it in their own module XML files. So what happens is, you run through these rules. This hopefully will become clearer as I go. And you check the conditions for a given rule. And if those conditions are met for this particular permutation, then the rule fires and it does some sort of substitution. Okay, so I know this starts to get complicated, but I can write a rule that is replace with W if the type that is being passed to gwt.create is T. Does that make sense? So the compiler sees the gwt.create call. It consults the rules. There will be a rule that says, oh, they're asking for T? Okay, well, if they're asking for T, then I should substitute in W. But you can add additional conditions. So they're asking for T, and if the client property user agent is Internet Explorer, then substitute in the T for Internet Explorer class in that case. This will make a lot more sense if you look through more examples, but this is just to kind of whet your appetite. There's another thing you can do. Not just statically in your XML do you have to specify that this gets substituted for that. You can actually generate code to satisfy the gwt.create call. Now, this is pretty sexy. So somebody can do gwt.create of some class that doesn't even have an implementation. It's just an interface. We find a rule that matches that particular gwt.create call. We see that, oh, this is a generate with rule, which has an associated code generator that's open-ended. You can plug in your own code generator. So you plug in a code generator. It then passes the t.class to that code generator and says, hey, give me some sort of implementation that I can give this guy. So the code generator runs. It does whatever it wants to do, spits out Java source code, returns the name of the substitution class, and the code that it generated gets compiled in monolithically and optimized with all the rest of the library code. So let's look at a more concrete example. This is what I referred to earlier, but here's how it looks when you kind of put it all together. So this is an example of a rule, a static rebind rule. When the type is DOM-impl, in other words, somebody wrote gwt.create DOM-impl.class, and there's an implicit and around all the conditions. And when the client property has the value, the client property called user agent has the value opera, then replace DOM-impl with DOM-impl opera. So hopefully that doesn't look too complicated. And so even though trying to explain deferred binding as a whole does get kind of complicated, with the actual mechanisms of using it, ought not to be complicated. And we don't think they really are actually that complicated. Simple rules, a simple programming model. You do gwt.create, you get an abstract interface, and you code against it. Everything just happens to get optimized. Now, compile time code generation is kind of radical, to be honest, and it's rarely done, and it's something that we use very heavily in Gwt. So as I said, you can have a different rule that is a generate with rule. And we do this all over the place in our standard libraries. It's one of the most powerful things that we do. If you've done RPC with Gwt, you should be familiar with this. There is a rule when you inherit the user.gwt.xml module that reads like this. If there's a gwt.create call to a class myService that happens, and then myService happens to be assignable to this well-known remote service tag interface. That's up on the top. Then, generate the replacement class using the service interface proxy generator. So this rule, the conditions are satisfied because myService is assignable to remote service. The code generator gets cranked up. It gets handed the myService class information. There's actually a whole compile time abstract syntax tree that's part of this code generation subsystem. It's called type oracle. So I hand the code generator a type oracle that has all this rich API information about my service, which is where you define your RPC methods. Then that generator automatically walks the entire graph of types, and it says, okay, well, his parameters are types A, B, and C, so I need to figure out how to serialize and deserialize those types. And the return type is X, so I need to be able to serialize and deserialize X. And it produces a my service proxy that you never even see as a developer. It just happens during the compile automatically. And then it gets substituted back in so that your gwt.create myservice.class gets replaced with new myservice proxy. Then all the optimizations we talked about before start to kick in because it's not a polymorphic dispatch. We know what that class is now when we compile, so we can inline and do all the great stuff that I talked about before. This is how RPC works. This is also how localization works. This is how image bundle works. If you haven't seen image bundle, it's really cool. You define an image bundle type that extends image bundle. You provide a sequence of methods. Each of those, and those methods return an image widget. Then I gwt.create my image bundle class. The compiler runs the code generator. The code generator for each of those methods goes and finds the JPEG or GIF or PNG or whatever on the disk. Right? It combines them all into a big image strip, and it generates an implementation of your image bundle class such that the image that's returned is actually a small sprite, which is a viewport into the combined image file. Now, I'm not actually showing an example of that because you can just do a Google search for image bundle and you'll see great code examples that will make this crystal clear. But the net effect is this is kind of a radical thing that transforms dozens of HTTP requests for images down into a single HTTP request for a totally cacheable image strip. And that's all through just using the normal standard capabilities of deferred binding code generators. You can just really start to imagine all the different ways you can use code generators. Ray Cromwell has a talk called Gwt Extreme, and Ray is not a Googler as much as we try to hire him, but he has done some really fantastic stuff with deferred binding code generators, and he's going to talk about that in his talk, Gwt Extreme, which I think is tomorrow, but double check the calendars. Okay. Finally, the last thing we care about, as we've harped on, is startup speed. We want it to be fast as possible. So I kind of already talked about how permutation is selected, so I'm going to go really fast here. But there is a two-phase startup. The first thing you have to do is decide which permutation you should load. So that's why it's two-phase. Phase 1, decide. Phase 2, fetch. The client, the host page to which a Gwt module is attached, downloads something called nocache.js. And it's called nocache because you want to make sure that that file, which contains the names of the different permutations, is fresh. Because when you deploy to the server, you deploy this selection script, the nocache script, along with a set of strongly named permutation compiled code files. So you fetch this selection script. The property providers all run that point to a particular permutation. And then, and this is what it looks like. So if you look at your .nocache.js file, you can see that, for all the different property values, there's an entry in some map. And so you run the property providers, plug those into that map, and that points you to a particular permutation. Now, you never have to really see or investigate any of this stuff. It's all magic plumbing. But you can look at it if you want to, and this is sort of what it looks like. Now, notice that these files are .cache.html and .cache.js. This gives us what we call perfect caching, and it's really, to me, the icing on the cake of this whole deferred binding faster than possible story. It turns out that the natural and required two-phase startup is the perfect opportunity to have a really efficient bootstrap mechanism. So the nocache.js file, the selection script, is small and has must revalidate semantics. In other words, I have to know that I'm not getting a stale copy. So nobody along the way should have cached it. I've got to go back to the origin server and get a known recent version of the selection script. But it's very small, so that request should happen relatively quickly. The strong name .cache.js files, in other words, the big compiled output, that has cache forever semantics. Okay, so think about what we've got here. We've got a small request that always has to happen, and a large request that ever only has to happen once, ever. Like, you don't even have to do an if modified since check. If you know that the selection script is up to date, then why even ask the server if my compiled script is fresh? Its name is unique. That MD5 name that you saw on the previous page is a function of the script's very contents. So no two permutations that have been compiled at different times could ever be confused with each other. So you trade off the download of something small that you always do in exchange for never having to download something big twice. Perfect. You never fail to get the newest things when it's updated, because you always do go back to the server to check for the most recent version. And then you never even ask if it hasn't been updated. You never even have to do an if modified since. And if you remember the outgoing request limit of 2 HTTP requests, things like not having to do a pointless if modified since round trip, that really adds up if you're doing some big application. You don't want to waste time doing a request when you know that the answer is not modified. What a waste. And if you're super cool, you can remove one of the HTTP requests by actually inlining that selection script directly into the host HTML page. So if you're interested in really, really low latency, because you're always serving up a fresh HTML page sort of at the top level, instead of having a script tag that pulls in the selection script, simply take the contents of that selection script and inline it. It's really easy to do that with a templating engine or something like that. So to wrap all this up, single Java code base. Gwt.create is the only junction point that you really need, and it's mainly the only thing you worry about typically when you're writing code. You use polymorphism as you always would. So you get one nice single Java code base. You download exactly the code that you need, none that you don't, in a single, highly optimized, monolithically compiled, can't go wrong chunk. If you get the code, it runs. You don't have to worry that, again, that fetch number 14 out of 39 different JS requests fails. You don't have to worry about that. If you get it, it runs, it can be cached, it works. So we've accomplished our mission. We've succeeded to realize the diagram at the very beginning, and we've gotten a lot of speed out of it to begin with. And this is an approach that you would just never really do by hand with JavaScript. All right. So big picture, although I think I'm starting to be redundant now. Gwt.create plus your module XML is compile time forking, giving you permutations. You can also do compile time code generation. Each permutation is independently optimized. We have two-phase startup. That's how it works, and it enables perfect caching. And hopefully the result is that you'll have happy end users. That's my spiel. And I think we actually have time. Do we have time for QA? Is that clock in the back right? Okay, perfect. We have 10 minutes for QA, which is great. So let's talk. Yes, in the back.
Why do you call it deferred binding? I mean, it looks like that you're binding things early, as you mentioned, right at compile time. Why do you call it deferred binding?
Why do you call it deferred binding is the question. That's a darn good question. It just seemed like a cool name at the time. Well, I mean, it's not dynamic binding, and it's not early binding. I mean, it is closer to early than dynamic. It's closer to early than late. But when you're actually writing Gwt.create, you're not saying, Gwt.create DOM impl Mozilla. You're saying something else. So there is a sense in which you're deferring the decision about how it gets bound to the compile time. So it's just a mildly delayed binding relative to static early binding. Just would be a mouthful. We just made the term up, but it's out there now, so we're going to have to kind of just keep explaining it the same way. Do we have a microphone for folks to use? Yeah, there's in the middle. It would be really useful if you could. Oh, there are two mics. Oh, yeah, okay, up here. One up here on the other side, too.
Hi. So you had an example earlier of vector graphics where you had, I guess, kind of a higher layer over the canvas tag or SVG or that other thing.
Yeah.
Is that just an example of how you would use deferred binding, or does that sort of general API for vector graphics actually exist within GWT?
Oh, that's a great question. So we've been using that as an example for like 2 years now, and about 3 months ago we actually built that. And it is, I believe, guys, we have some GWT engineers here. Is it in the incubator now? Does anybody know? I think it is. I know the guy who wrote it, and I saw his demos, that work exactly the way I described.
So in the incubator means it's publicly available or not yet?
Yes. GWT has a sibling project called the Incubator, where we vet, things that we know we want to make part of GWT, but we want to get feedback and people to use it.
So just search for GWT Incubator Vector Graphics?
I would try that, and if that does not turn up results, I would go to the developer forum, which is a Google group for GWT. It's linked really clearly. And I can tell you, all of us on the engineering team read almost all of those messages, so you'll get your answer there. Who's next? I think you're next.
Okay. Bootstrapping question, where the no-cache HTMLs are mapped to a unique file handle.
Yes.
Is there any, elegant way to change that in case you have container rules around how you want to map URLs, like if you want .htm or something other than the no-cache.html?
Actually, yes, there is. In fact, that's something that Bob, did you do your linkers talk already?
That was my question, whether it had to be a post linker or if there's some other way.
Okay. So the answer is that we realize people have different scenarios for deployment, and so we introduced this linker subsystem in GWT now with 1.5, where you can decide how all that stuff kind of gets fit together.
Okay, great. Just want to make sure that was the right avenue to take. Thanks.
Yeah, the linker would be the right. That's true, right, Bob? That should be a no-brainer with linkers, right? That's what linkers are all about. And if you didn't catch Bob's talk on linkers, go back and look at the video of his talk afterwards. I think you might have been next, please. Go ahead. Is it possible to use Spring to create the bindings? Can you clarify how you might use Spring to do that? Interesting. So I've not seen a direct example of how you might be able to do that. As I understand it, the Spring decisions are made at runtime. I think Juice is the same way. Whereas deferred binding is really all about compile time. So by the time you're even running code on your server, GWT is not in the mix at all anymore. What you have is a selection script, which is a generated JS file, and a stack of static JavaScript files. So all of those decisions have been made long, long ago at the on the build machine. Maybe you could do some sort of transform from Spring rules into deferred binding rules or something like that, but probably would not bear a lot of fruit, to be honest. Yes.
Can you speak to the relationship, if there is any, between GWT and the Caja project? Is there any hope of maybe using the same compiler optimizations to get rid of some of the runtime checks and sanitized code?
So the Caja project is a project that is attempting to make handwritten JavaScript. I guess you could say I'm not on that team at all, so I don't want to misrepresent what their goal is. To make it trustworthy, so that I can run foreign JavaScript code without worrying that maybe somehow it could do some damage to my system. In other words, sort of sandboxing JavaScript code. So what they do is they take handwritten JavaScript and they do some stuff to it to try to make it ensure that it stays within a sandbox. And in theory, yes, there are ways we can apply some of the same techniques, but there is also a theoretical limit to how much we can do that. We inevitably get drawn into debates, unfortunately, about statically typed languages versus dynamically typed languages. Honestly, none of us is on the GWT team are particularly religious about the point, but what we do observe is that statically typed languages are can be analyzed with tools, right? You can thoroughly analyze and type check a Java program. Well, you don't get that same amount of ability to understand what's happening in a dynamically typed language because it's by definition dynamic. So consequently, there's a limit to how much static analysis you can do when the source language is a dynamic language like JavaScript. So it will become more possible as JavaScript gets more static, features. And so to the extent that JavaScript becomes almost just like Java, you can see that the optimizations and checks start to overlap a lot more. Yes.
Okay, so
this is going to be the last question.
Okay, so I have a good imagination for different axes of permutation. I can think of all sorts of different things that could be dependent on the user, could be dependent upon the merchant who has a particular website, or the sponsor of a website, the design, sort of scheme, styles, all sorts of things. And so what I would like to know is, I can swallow the idea that maybe when I want to create my deployables, I have zillions of JS files for all these axes of permutation. What is let's say we get to a fair number of different axes of permutation. What would you suggest for dynamically selecting these different the right files and then maybe bundling them and because essentially what I'm dealing with is a system that has to do all these sorts of decisions at runtime. So at runtime selecting the different static resources, is that what you're talking about with the selector script?
So yeah, the selection script it is downloaded first in the browser, and then it basically says what are the values for the client properties in this current environment, and there is a pre-built map built at compile time that says if user agent is this and locale is that, then it go fetch this particular permutation script. That's what a selection script is. And for things that might change at runtime, literally might change at runtime, like, potentially, what are some examples? Like if you've got product images that you fetch from a database, for example, that's not a good thing to use deferred binding for because that by its nature needs to be a dynamic fetch. The database can change at any time. You need to do a request for that. Deferred binding is for things that, that really don't, that wouldn't be dynamic as an application were to run. Like the locale is not going to change typically during an application run. You might switch to another page that has a different locale, but you would kind of do it at the whole page granularity. You'd go to a different, restart the app essentially. The last point I want to make, this sort of triggers it, is that people do sometimes get a little bit intimidated by the idea of zillions of compiled output files. Think about two things, okay? One, if we zipped them all automatically and the compiler ran and it gave you one file, it would feel better. Right? Wouldn't it? It would seem so clean and nice and simple. But that's just, come on, that's just lipstick. It's the same thing. And we all know this. And we can zip it ourselves if we want to. You can create a WAR file from it as part of your build process. So don't get intimidated by that. Which brings me to point number 2. The reason it is totally worth it, the reason that you should challenge anybody who says this is not a good approach, is look at the economics of the situation. What is the cheapest thing anywhere? Disk space, right? Disk space is, hard drive manufacturers are practically paying you to go buy their hard drives at Best Buy, if you look at some of the rebates. Huge hard drives, okay? So you've got all this space. Now, what is precious? Things like bandwidth, CPU power, but most importantly, user attention, right? When people get frustrated with websites and they abandon your website, that is costly because you've just lost a sale or a customer or user. So what deferred binding fundamentally offers you is the ability to exchange very, very cheap server disk space for extremely high value things like users' time and attention by providing the ultimate in low latency responsiveness for your application. I think that's a deal definitely worth making, and that's the one that we're betting big on with Gwt. And I think the results really kind of speak for themselves when you use a high-end application built with Gwt. Thanks very much. We look forward to talking to you more.